Hi everybody, welcome back to YouTube channel Maths Insights. In this video, I am going to start a new chapter called Trigonometry. This trigonometry is finding questions not only in academic classes but also in different competitive examinations. And this trigonometry is a very big chapter, and hence I decided to make different videos by making them into different parts. In this part 1, we are going to have an introduction to the chapter trigonometry, and after that what are the trigonometric ratios, and we will solve some problems. Before going into the topic, you have to know what is actual meaning of trigonometry. The word trigonometry is a Latin word which is derived from Greek words. So I am writing this trigonometry actually is a Latin word, right? This word is taken from Greek words, derived from, actually this is derived into three words, that is tri, gonon and metron. These are Greek words. And you know, tri means 3, gonon means angle, metron means measure. If you combine these two words, triangle means actually it will become triangle. Triangle measure. So it is very clear that trigonometry is a branch of mathematics which measures triangle. So trigonometry is all about measuring triangle. Triangle will have 3 angles and 3 sides. In other words, you may say that trigonometry is a branch of mathematics which establishes the relation between angles and sides of a triangle. Before going into trigonometric ratios, you have to know what is meant by angle. So I will explain it briefly, and for this I made a separate video. I have given the link, the video at the end of this video. You may watch that video also on angle. And after that you have to know what is meant by a right angle triangle. You may have seen a painter painting to the wall. How it will be? If this is a wall, then this is the ladder he is having, and this is the distance between wall and the ladder, and then there will be an angle between the ladder and the base. And also you may have seen sliders in the park used by children. If you observe, sliders may be like this. See, there will be a base here also. So this is also a form of triangle where angle is formed between the slider and the base. Here also you may have a ladder to step up, and this is the angle between the ladder and the base. And again, if you observed an electric poles, see, this is an electric pole. They may have tied with a wire to make it strong. So if it is a wire, then there will be formed an angle between the wire and the base, and this is called angle. In all cases, you may observe that these are all right angle triangle. See, the angle between this and this is 90 degrees. Here also the angle between the wall and the base is 90 degrees. Here also the angle between the pole and the base is 90 degrees. In all these cases, we may find different values, like distance between the electric pole and the wire, otherwise length of the wire or length of this electric pole. In all these cases we may find different values. So from these three figures we have to conclude that trigonometric ratios are defined only in a right angle triangle. Basing on this right angle triangle, we will define the trigonometric ratios. First, before going into definition of trigonometric ratios, we have to understand some terminology in right angle triangle. All of you know, a right angle triangle is a triangle in which one angle is 90 degrees and the sum of two remaining angles is 90 degrees. Why? Because sum of three angles in a triangle must be 180 degrees. Therefore, I am taking a right angle triangle A, B, C. Then this is 90 degrees. It's very clear. Why? Because they are perpendicular to each other, and you have an angle called theta, let. Then it will become 90 minus theta. If you add these three angles, you will get 180 degrees. In this right angle triangle, the side BC is called adjacent side to this theta, and this side AB is called side opposite to theta. In other words, the side adjacent to 90 minus theta is AB and the side opposite to 90 minus theta is BC. And in right angle triangle, the hypotenuse, this AC is called hypotenuse. This is the largest side in the triangle. Basing on this, we will derive the trigonometric ratios. Trigonometric ratios, the first one is sine, actually SINE. We will simply write it as sine. See, if you want to define sine with respect to theta, then we will write sine theta. Otherwise, if you define the trigonometric ratio sine with respect to 90 minus theta, you have to write sine 90 minus theta. But generally I will take sine theta, and I will say that the ratio of side opposite to theta, this is the theta and this is the side opposite to theta, that is AB by hypotenuse. This is the side AC which is called hypotenuse, that is AC. Similarly, I am drawing a perpendicular here to this triangle. Let it be PQ. I have another triangle here, PQC. In this also, I will take the ratio of side opposite to theta. See, in this case, side opposite to theta becomes PQ by hypotenuse. In this PQC, PC is the hypotenuse, therefore I am writing PC. Similarly, I am taking another triangle, another perpendicular to the side BC, let it be XYC. Then you have another triangle called right angle triangle called XYC. In this also, I will find the ratio of side opposite to theta. This is the theta, and the side opposite to theta in XYC is XY. Therefore, XY by, then hypotenuse will become XC. If you observe all these ratios in the similar triangles ABC, PQC, XYC, these are all similar triangles. If you want to know what are meant by similar triangles, I have made another video on that. You may see that video also for knowing what are meant by similar triangles. At the end of this video, you may have access to that video also. So what I am going to say is these ratios are equal. These ratios are defined as the ratio of side which is opposite to theta by hypotenuse. In all cases I will have, therefore I find that these ratios in all similar right angle triangle are equal. Therefore I will define that sine theta is equals to side opposite to theta by hypotenuse. Second ratio, this is the first ratio. Coming to second ratio, that is called cosine. Actually cosine, we may write it as cos, simply cos theta. In this case also I will take the ratio of side adjacent to theta by hypotenuse. Now I am taking first triangle ABC. In this ABC, angle B is equals to 90. Therefore it is a right angle triangle. The ratio of side adjacent to theta, BC will become side adjacent to theta by hypotenuse will become AC. And also in the second triangle PQC, I will take the same ratio, that is ratio of side adjacent to theta, that means QC by the hypotenuse will become PC. Okay, and if you take the triangle XYC, which is also a right angle triangle, in this angle y is equals to 90 degrees, therefore side adjacent to theta will become YC by hypotenuse is XC. In all these ratios are equal to each other. Therefore in all this right angle triangle, the ratio of side adjacent to theta by hypotenuse is same, and that is the definition of cos theta. Therefore cos theta is equals to side adjacent to theta by hypotenuse. Similarly, you have the third trigonometric ratio, that is tangent. This is very important. Simply we will write it as tan theta. Okay, tan theta is defined as side opposite to theta by side adjacent to theta. Therefore if you take any triangle ABC or PQC or XYC, now I will consider the big triangle ABC. Therefore AB by BC is the ratio of tangent. Similarly the fourth one is cosecant. This is simply written as COSEC, cosec theta. Cosec theta is actually reciprocal of sin theta. Actually sin theta is defined as side opposite to theta by hypotenuse. So we will reverse. That means hypotenuse by side opposite to theta. So if you take triangle ABC, it will become reciprocal of this. See, AC by AB. And coming to fifth trigonometric ratio, that is secant theta. Secant is simply written as sec theta or secant theta. So it is also reciprocal of already defined cos theta. Cos theta is defined as side adjacent to theta by hypotenuse. Therefore we will reciprocate it, means we will do 1 by, then numerator and denominator will interchange, that is hypotenuse by side adjacent to theta. If you consider the right angle triangle ABC, the ratio will become opposite to this one, that means AC by BC. AC is the hypotenuse by side adjacent means BC. And the last one, that is cotangent. Cotangent. This is simply written as cot theta. Cot theta is the reciprocal of already defined tangent theta. Tangent is defined as side opposite by side adjacent. Therefore, it will become side adjacent by side adjacent to theta by side opposite to theta. Side opposite to theta. So if you consider the triangle ABC, then it will become BC by AB. BC by AB. In this way, you will define these 6 trigonometric ratios which are very important to solve different types of problems. By using these trigonometric ratios, we will define heights of buildings, heights of poles, heights of human beings, and the distance between the pole and the man who is observing the pole. So we will apply these concepts to finding heights and distances, and also slopes are very important. In the next video, we will apply all these trigonometric ratios and we will solve the problems. If you like my video, kindly don't forget to subscribe to my channel and press bell icon to receive more notifications when I upload a video. Until then, have a nice day. Thank you.